Welcome to the Esri Developer Summit presentation of Python Working with Feature Data. My name is Ghislain Prince, and my co-presenter today is Danny McVie. Both of us work on the Python team here at Esri. This presentation is about working with feature data using the ArcPy Python package. We won't be talking about the ArcGIS API for Python in this particular presentation, though if you search the Esri Developer Summit videos, you'll find dedicated presentations on that subject. All presentation materials that we're able to share will be made available at the URL at the bottom of this slide. First, let's establish some feature class basics. When we're talking about feature data, we're primarily talking about feature classes. And feature classes are defined as a collection of features that share the same geometry type, say points, lines, or polygons. And these are typically stored in a geodatabase or a feature class. Here's what a feature class looks like if you open its attribute table in ArcGIS Pro. What we have is individual rows, which we call features. These are typically distinct event, places, or things. The table's columns, which we also call fields, store properties of each of these events or features. In the example on the screen, you can see the city names. Field is selected. Finally, this is what distinguishes feature classes from regular tables. We have special fields called shape, typically called shape, which contain geometry objects. The Python library we'll be talking about today is called ArcPy. It's a powerful library for doing data analysis, conversion, data management, as well as map automation and other things. ArcPy provides the Python API for functionality that is delivered by an ArcGIS product. This means that the ArcPy Python package can't just be dropped onto a machine and used. It always comes with an ArcGIS product. The ArcPy library is included with many ArcGIS products. If you use any of the products that you see on the screen, you probably have access to the ArcPy library. ArcPy provides extensive functionality. If you're familiar with geoprocessing tools found in ArcMap and ArcGIS Pro, all 1,400 of them are available as methods on the ArcPy library. Additionally, there are submodules containing general utilities to do things such as query and describe your data, as well as generate lists and interact with your data in various ways. Additionally, ArcPy has a list of submodules tailored to specific data needs and use cases, such as modules for working with metadata or network data sets. Now let's look at some specific methods that you can use for feature data processing. The first of these are cursors. Cursors are a way to interact with individual features or rows in a feature class. These cursors come in three flavors: update and insert cursors, as well as the search cursor, which is a read cursor. With these, you can do classic database CRUD operations, CRUD being an acronym for create, read, update, and delete. This is not to say that this is the only way to perform CRUD operations, as there's geoprocessing tools available to do this as well, but the cursors let you do this on a record-by-record basis. A simple code example showing the use of an insert cursor. The code is really minimal. The only parameters provided are the input table and the list of fields. There's many additional optional arguments that you could provide when creating a cursor, but these are optional, and you can get more details on those in the user documentation. A really important takeaway from this slide is that when you create a cursor, you specify a list of fields in some order, and when you either retrieve or, in this case, insert new rows into the table, you provide the values in the same order as the list of fields you provided. The with statement is known as a context manager in Python. This is a way that objects can implement additional logic that runs when they're created and also destroyed. This works really nicely with cursors, since part of the processing they do always establishes locks on the data. And the context managers that are written into these cursors always ensures that upon destruction, the data logs are released. In the past, without these context managers, it was quite difficult to write correct logic to do this. So what we recommend people is to always use context managers with the with statement when working with cursors. Cursors are not the only objects on ArcPy that support context managers. If you read the documentation, you'll notice other ArcPy classes that also support it. Now let's have Danny show a demo of cursors in action and show you some interesting things you can do with them.
In this demonstration, I'll show you how to use cursors with feature data, implementing a search cursor and an update cursor to find and clean invalid values in a dataset. In this Jupyter notebook, I will be accessing the data in the map, this accidents layer, which contains about 30,000 records, some of them with invalid light codes. So we're going to use a search cursor to examine the data and an update cursor to remove invalid records. Let's get started. This first cell just imports some libraries and sets an environment variable. Here I'm going to describe the data using getCount and list fields to show how many records there are and a little bit of information about the first 10 fields in the dataset. Light code is the one that we're interested in. As you can see, for the purposes of this exercise, we consider only some of the values in that field to be valid. The others are invalid. They don't give us much information, as you can see. So later on, we'll be selecting for those. In this next cell, we start up a search cursor to examine the data. Let's see what happens when we just use a simple search cursor, minimal syntax, just search cursor with the layer name and asterisk to indicate all fields. I have a break statement at the end of this loop, just so we stop after one record. So this is the data for object ID 1. And as you can see, just a tuple, comma separated values here. Not very nice to look at. If we wanted to look at that by index, you can add in list operations here and bring out just the first couple of fields. If we remove the break, we get every single row. Since all fields is too much information, it's recommended to look for the fields that you're interested in. For instance, this exercise, we're interested in the light condition for each accident. So I'm going to specify the fields after the accidents and the list of fields. That's how the cursor syntax is. Let's see what that gives us. Object ID and light codes for every record in the data. Great. The third parameter on a search cursor is an optional where clause. So let's specify those invalid light codes here. Where clause equals light code in 0, 88, and 99. As you can see, the where clause is in the search cursor, and when we run this cell, we get only the records that correspond. Finally, let's use update cursor to remove the records with invalid light codes. When we use arcpy.da editor, we're protected from bad editing. The changes will be committed only if the operation is successful. If an error occurs before all edits are completed, the transaction is rolled back. At the end of the process, I will print out the count just to show the remaining number of records. Remember, we started with 30,500. As you can see, we are missing about 1,000 records. That's good news. We're cleaning our data. So that's a brief overview, just to get you familiar with data access, how useful that can be to have programmatic access to your data in many ways.
As Danny showed in his demo, there's some special values you can set into the field name argument. One of them is a wildcard or star character. This comes from the SQL syntax that everybody's familiar with. And what it does is it tells the cursor to pull all the fields into the cursor. The problem with using it is that typically when you're writing code, you're working with a known set of fields, and pulling all of them into the cursor will slow down the cursor. The other problem with the star is that the order of the values in the list becomes unclear. Finally, when you're working with geometries, we use the equivalent of the shape at XY as a performance optimization. So in the instance of points, this is okay, but if you're using lines or polygons, the shape at XY will be basically the centroid of those geometries, which may not be desirable. Another notable thing to mention here is that there's a set of special tokens that can be used with the field name argument. These are shown on the right. They're easily identified as they each contain the ampersand character. These are useful because they're based on the field type, not the name of the field. For example, OID add will get the object ID field, no matter what the name of it is, since sometimes it's called FID, OID, or object ID. The other special or tokens that you can use here are primarily geometry operations. These let you optimize your code, since some of these numeric values can be converted from the backend database into your cursor much more quickly. For example, if all you're going to use from the geometry is the area, you can just ask for the area value instead of the entire geometry object in order to query the area property on it. Creating and editing geometry objects can be done by using the geometry objects directly, as they have operators on them such as clip, buffer, and union. You can also interact with the individual vertices that make up a polygon or polyline geometry. Some of the common coding patterns are seen on the screen here. Since the very beginning of the geoprocessing project in ArcGIS Desktop 9.0, discovering and iterating over data has been a critical functional requirement. The ArcPy library has a variety of functions dedicated to listing and discovering each type of data which we support. These functions let you do things such as find all the domains in a geodatabase, list all the rasters in a folder that have a name which begins with the letter A, or list all the point feature classes inside of a feature dataset. Most of the data iterators we saw in the previous slide act on a single specified folder or workspace. A really interesting data iteration function that we've added is called walk. It takes as an input a top-level folder, and what it does is it walks through all the folder's contents, including the subfolders and database connections, and finds all the data sets which match the specified requirements. On the screen is what the typical code looks, which is used for working with arcpy.da walk. It's a bit more complicated than just the list operators, and it may take a long time to run depending on the amount of data that's been walked through, but the code saves a lot of time, especially when compared to doing it manually. The arcpy.da walk is modeled after a similarly named function found in the Python OS module.
In this demo, we'll talk about traversing datasets with arcpy.da.walk. First, we have a simple demonstration of a code sample that can be found in the documentation for spatial references using arcpy.listFeatureClasses to describe each feature class that's found in a certain workspace and print out the spatial reference. If an unknown spatial reference is found, it prints something different. First, we're going to list the feature classes and count them. 26 in that file geodatabase. Now we'll loop through that list, print out the information. Let's see, quite a few, and roads_1 and roads_2 are the feature classes in there with an unknown spatial reference. All the rest of them are WGS84. Here's a more complex example that does a similar function but using the power of arcpy.da.walk, which is just like os.walk, if you're familiar with that, in that it traverses recursively all subdirectories as well. In this case, if an unknown spatial reference is found, the path to that is written in this blank text file, unknown.txt, is standing by to take output. So let's run this cell, see what happens. And again, we get a much longer list because it's not only traversing this folder, but any directories that are found underneath it. Great, now that that's done, let's check out the text file and see if we have output. Nice. So that's just a short demonstration of arcpy.da.walk. Hopefully you can take these code samples and they'll be useful to you.
Now let's talk about how you can use ArcPy to interoperate with external Python libraries. NumPy is a fundamental package for scientific computing in Python. NumPy provides a multidimensional array and a long list of routines for fast mathematical, logical, and statistical operations. NumPy arrays are used in many other libraries for the computation as well as the internal representation of the data. Additionally, many other libraries have NumPy converters, and since ArcPy comes with functions to import and export tables, rasters, and feature classes to NumPy arrays, this allows you to efficiently transfer data between ArcPy and these libraries. There are 5 functions found in the ArcPy library that can be used to convert to and from NumPy arrays. They're shown on this slide. The first 4 are fairly self-explanatory. The 4th, extend table, adds the contents of an array to an existing table as new fields on existing rows. The values from the array are matched to the existing rows based on a join operation. The functions for converting tables and feature classes to NumPy should be familiar to you, as they're designed to be very similar to the cursors we talked about earlier in this presentation. At minimum, the feature class NumPy array takes a table or feature class as input and a set of fields that you want to convert into the array. Since NumPy arrays are contiguous blocks of homogeneous memory, the NumPy array imposes some limitations, especially on null values, and therefore these functions have additional parameters allowing you to define how these null values are handled. You can also turn NumPy arrays into tables or even directly into feature classes in the case of arrays containing XY data. In the code example on the screen, you can see that we have a NumPy array that we're defining, which contains 2 values, the first being an integer by the name of ID field. The second is a tuple of 2 floating point numbers. These are what we're going to turn into the XY coordinates of points in the output feature class. NumPy has detailed technical API for declaring and working with arrays, as shown in the dtype parameter on the first line. Now Danny's going to show us some presentation on working with NumPy as well as Pandas.
In this demo, I'll show you how easy it is to convert feature data into a NumPy array, what types of operations you can do with it, and demonstrate Pandas. I'll show a data frame here in this notebook in ArcGIS Pro. Let's get started. Here's arcpy.da.table to NumPy array. USA counties is the layer over here in the table of contents. So we can access it just like that. Similar to da.searchCursor, we can specify a field. So let's create an array in this first cell, and in the second cell, we'll examine some of the attributes. The length is the number of records. That is a string representation of the array. Notice how it's nicely concatenated for us to show us the beginning and end of that. And the data type here in NumPy, that's a little endian 4-byte or 32-bit integer. If you're using NumPy, you probably care about memory usage, so all of that data type information gets really specific. Here in ArcGIS, we would just call that an integer. Moving on. NumPy makes it easy to do mathematical operations. Now that we have an array, I'll show you sum, standard deviation, minimum and maximum of that. And here we are converting more fields than just the population into a multidimensional NumPy array. And again, printing the array, it's concatenated. You see the ellipsis here, and data type for each of the fields. Let's do some more math. Here we can easily calculate the population density. That's overall. As you can see, we're using sum in line here to aggregate. Now, moving on to Pandas. Pandas is built on top of NumPy, so as an input to pd.data frame, you could just put your array object. We'll print some information about the columns and the top of that data frame. His head right there. But of course, now that we're in a notebook, data frames have a really friendly representation here. So I won't use a print statement in this last cell. We'll just print the data frame. And we'll use group by, something that Pandas gives us that it's pretty tricky to do outside of this interface. Here, grouping U.S. counties by state and summing the population and area. So you get this cool HTML data frame.
All right, thanks, Danny. So where NumPy is sort of this bare metal, sort of complicated library to use, Pandas is a lot more user-friendly, a lot easier to work with. It also provides high-performance operations because actually it's sitting on top of NumPy. What it does is augment or add further functionality to it and is a lot nicer to use. On this slide, we have two functions, one to import and one to export a feature class to a NumPy array. There's actually a built-in function in the ArcGIS API which does this already. So have a look at that library if you want to get data into Pandas data frame. So this concludes the presentation on processing feature data with Python. It's one of many presentations that we have this year at the Developer Summit. There's many dedicated presentations for the ArcGIS API for Python. There's a sister presentation to this one called Python Working with Raster Data, exploring more of ArcPy's offerings when it comes to raster processing. And there's many, many presentations about data science and basically the platform itself, doing raster process, using Python as part of the ArcGIS platform. So Esri's committed to Python. We keep growing what we offer to the Python language, and we hope you guys are happy and successful with those offerings. Good luck, and come see us next year. Thanks for watching. Thanks for listening.